Hello everybody, so we're going to go ahead and start chapter 4, and we're going to start off this chapter by starting you guys simple. Alright, when this whole chapter has everything to do with triangles, and for this first section we're only interested in you being able to classify the triangles, and we'll show you the different variations of the problems that you'll likely see on the FSA. So let's just get right into it. If we look at the different sides of the triangles, there are three types of triangles you have to be able to identify from the sides. So first of all, if there are three congruent sides, okay, then that means that we have an equilateral triangle. Equilateral. Okay, this is stuff I remember way back in the day from kindergarten. So hopefully most of this is a review, and if not, well, at least you're learning it now. So the next one is saying that if we have two congruent sides, then that is an isosceles triangle. Okay, two sides are the same and one is different, we have an isosceles triangle. And if none of the sides are the same, then that's what we call a scalene triangle. All right, so pretty easy names to remember. Hopefully this is, like I said, hopefully this is a review of what you've done in the past. And now if we try to look at the angles of the triangle, well, if we have three acute angles, in other words, acute being less than 90 degrees, then we have an acute triangle. It's pretty easy to remember. If they all acute, then it's an acute triangle. If you have one obtuse angle, obtuse being greater than 90 degrees and less than 180 for both of them, then that means that we have an obtuse triangle. This is the one most of us are familiar with because we've done Pythagorean theorem a lot. But if we have a right angle or one that has exactly 90 degrees in it, then this is a right triangle. Ugly triangle, but whatever. And then over here, if we have three angles that are the same, very similar to an equilateral triangle, but this is, we call this an equiangular triangle. All right, pretty hard to say, but that's what it is. So this is one style of problem that you'll see. They'll go ahead and say, they'll give you a statement, they'll give you some very complicated figure here, but from this figure you have a bunch of triangles within this whole figure. So we're going to go ahead and look at the different triangles in here and see if we can identify them, and we're going to have to use our knowledge of angles and sides to be able to say which one it is. So really when it comes to this problem right here, we're going to go ahead and identify it as two different things. As you know, we're going to say what type of triangle it is by the sides and what type of triangle it is from the angles. So let's just kind of go ahead and read this. It says if PR bisects triangle SRT. So this is PR right there. This bisects, and for those of you who don't remember what bisects means, that means cuts in half. So really this line right here cut angle SRT in half. So if we know that this cut this angle in half, then if this is 30 degrees, that should also be 30 degrees. When you cut something in half, it cuts it into two equal parts. And then we also know that U is the midpoint. So where's U? Right here. So U is the midpoint of RT. So again, what you have to remember about the midpoint is that it's located right in the middle. So that means that this side and this side are going to be the same. So if this is 8 meters, then this is also 8 meters. All right. And that's pretty much all the information they gave us. So they say classify each triangle by its angles and sides. So let's go ahead and look to see what the first triangle is. So the first one is saying UQR. So U, Q, and R. So they're talking about this triangle right here. All right. So first of all, you can already see that it has an obtuse angle. This angle is greater than 90 degrees and less than 180. So we can already say that it's an obtuse triangle. And then the other thing we need to know is that it has two sides that are the same. So this is 8, and that's, you know, the tick marks are indicating that they're congruent, right? So it's also, and this third side is not the same value as those, so we're going to go ahead and say that this is also an isosceles triangle. All right, so that's how we're going to go ahead and identify each of these triangles. Now this one, RST. So, okay, so this one they wanted to go a little bit more complicated. So R to S to T. So this big outside triangle right there. So right off the bat, I can already see that we have two angles that are the same. And this, if I added the two 30s together, that would also equal 60 degrees. So if all of them are the same angle, then that's telling us that it's an equiangular triangle. So I'll write that here. equiangular triangle. And what else do we know about this? And if we know that all of the sides are the same, right? Because first of all, you can see that this is 16. This is also, if I added the 2 8s, 16. And if I added these 2 8s, it's also 16. So it's also equilateral. Equilateral. Okay? And one thing you'll know is that if it's an equilateral triangle, then it's also equiangular. Just a little hint for the future. All right. Let's look at triangle SQR. So if I look at this one, well, first of all, I see that 90 degrees in there. So that's already telling me that it's a right triangle. And then, let's see. I also see that if this is 8 and that's 16, well, I'm pretty sure that if I did Pythagorean theorem, this side right here would be different than that, right? So we're also going to say that it's a scalene triangle. Okay. And the other thing you should know too is that if this angle and this angle and this angle are all different, then all of the sides are also different. All right, so if I look at triangle PRT, so that's this big outside triangle right here, right? Well, I have two sides that are definitely the same, so 16 and 8 are also the same. And then I can guarantee you that this over here is going to be different. So it's going to be 16 and 16, that makes it an isosceles triangle. And then we also know that if this is an isosceles triangle and this over here is 30 degrees and this is 30 degrees, right? Well, if I added those two and subtracted it from 180, then I know that this one right here is going to end up being 60 degrees as well, right? So this right here is telling us that it's an obtuse triangle as well. All right. So now let's look at triangle TQ. Where's U? Oh, TQU. All right. Well, let's see. This one, we have two sides that are the same, so we know that much. And then here's the thing. These two sides are also the same, and if this is 8 right there, right? So this is telling, these two tick marks telling you that these two sides are the same, and if this is 8, then that means that this is an equilateral triangle. And if you were paying attention to what I said like literally a minute ago, if we know we have an equilateral triangle, then that means that it's also equiangular by default. So we're going to put equiangular. All right. And then we're going to look at triangle PQT. All right. Well, right off the bat, you can kind of tell that this right here is 90 degrees. Because if you notice this angle and this angle, if they're opposite of each other, then they're vertical angles. So if this is 90 degrees, then this is 90 degrees. So that's telling me that this is a right triangle. All right. And very similar to this one, if this is 8 and that's 16, like this is 8 and that's 16, and that third side is probably going to be different when we do Pythagorean theorem. So we know that this is also a scalene triangle. All right. So not too bad. So this is the one that I've seen so many times on so many different FSA preps, and so many students have said they've seen this on the FSA. So we want to make sure that we understand how to do this one. This one is saying classify triangle JQKL by its angles and sides given the coordinates. All right. So let's go ahead and look at this. And what we're going to end up doing for these is we're going to take the distance between each of these. And really, you don't really have to worry so much about the angles. It's more, they care more necessarily about the sides. They want you to know if it's an equilateral, isosceles, or scalene triangle. So what we're going to do, if ultimately we want to be able to classify this triangle by its sides, we need to know what is the distance between like each point of a triangle. So obviously we have 3 points that make a triangle. We need to know the distance here, the distance there, and the distance there in order to be able to do that. So hopefully you guys like you doing the distance formula, because we're going to do it 3 times. So let's go ahead and first find the distance between JK. All right. So I have these 2 points that I need to find the distance of. So the distance is equal to the square root of, let's see, x2 minus x1, so -9 minus -7 will be +7 squared, plus y2 minus y1, so 1 minus -7 is +7 squared. So then that becomes the square root of, let's see, 2 squared. So this is going to be negative 2 in the parentheses. Negative 2 squared is equal to 4. 1 plus 7 is 8. And then 8 squared is plus 64. So that's equal to the square root of 68. And I'm just going to leave it like that. You could write out the decimal, but honestly, if you just leave it in radical form, you can still be able to compare the different sides. All right, so let's pick the next one. Let's do k to l. KL. All right. So we're going to do distance formula again. Distance formula being x2 minus x1, so negative 1 minus negative 9, so that'll turn into a plus 9 squared, plus y2 negative 1 minus y1 minus positive 1 squared. So that becomes the square root of negative 1 plus 9 is 8. 8 squared is 64. Here we have negative 2 again. Negative 2 squared is 4. So again, we have square root of 68. So we at least know it's not scalene because 2 of them are the same. So let's figure out if the last combination is the same. So the only combination we haven't done is JL. So now we're going to do the distance formula here. Distance is equal to square root of, all right, so let's do x2 minus x1. So negative 1 minus negative 7 will turn that to a positive 7. Plus y2 minus y1, so we have negative 1 minus negative 7 again is going to be plus 7 squared. So this becomes negative 1 plus 7 is 6. 6 squared is 36. This is also going to be the same thing of 6 squared, 36. So now we have the square root of 72. All right, 72, sorry. So right here, you can tell that we have 2 sides that are the same and 1 side that's different. So this is telling us that it's an isosceles triangle. All right. So that's pretty much it for the notes for section 4.1. I would, go ahead and get started on the problem set. And hopefully this was helpful. And if not, just make sure you ask any of us any questions that you might have. Take care.